So here we all talking about the wear, and one is for the wear models. The Professor Steele, he presented the new improvements on the wear models, and the U is the real data. Yeah, and these two persons, they have the different models for the simulation. One is for locomotive, and the other one, yeah, one is for the general high-speed train. Yeah, okay. So he have the same topics, but are different for different levels. So could you say something if you have not finished? You want to say for one question, maybe one by one. Maybe firstly, Professor Stich.
Yeah, perhaps again the main idea, the main message is that we want to come up with a wear model that is based on the physical behavior of the contact partners, to not rely on experiments, and to have the possibility also to calculate the wear behavior for the exact combination we want to investigate, not extrapolate a wear map, for example, that was developed for completely different contact partners.
So do you think are they all use your model in your simulation? Not? That
they
means
all use
the
model we use today, yeah.
Mm-hmm. So you should to update the new models. Okay. The second person, Mr. Duan Liang.
Yeah. In my presentation, I see that the wear is very difficult to predict, totally by simulation.
It's influenced by the weather and condition also. Yeah. Yeah, your topic is, your conclusion is the wear will be influenced by the environment.
Yeah.
So it is very hard to predict it by simulation.
We have conducted the simulations in the real world, and the results is not completely satisfied by us.
Yeah, do you have compared each other, simulation and the real test?
No, because it's related to the high-speed EMUs, so we are very cautious. We are very cautious about its.
Okay.
Yeah. Okay.
And Mr. Tao, and your no, Mr. Yeah. You.
What?
I can later make a comment because we have.
声院，倒是声院。
measured wear and simulated wear for your
and the influence of the track rhythm irregularity and the vibrations of where dynamic interaction of along the track is different of different section. So their value of different cross section are different. Their value is non-uniform along the track. Their non-uniform predictive model is could be better reflect the characteristics of their well. Hollow one well would not only influence the their dynamic interaction, but also have the effect on their non-uniform well along the track.
How about you? Do you want to say something more?
Hello. The service environment have a great influence on wear. The test results of Duan Liang demonstrated it. But how to simulate the influence of service environment is a very big challenge, because the wear function and we used is generally get in the dry condition, but They will function in world condition or in other condition.
Okay.
They
I know.
set the real model, real
That's
function.
enough because you haven't answered the question of Mr. Ding. His question is, do you consider in your simulation? Do you considering the whole train?
I don't consider the whole train, but the force, the resistance force, is applied at the end of locomotive. Yeah, it is represent the other vehicles of freight in my simulation.
Yeah, that means you included in the whole train. In your traction.
It is.
I believe your traction force is larger for whole train, but your braking force is only for one locomotive. Is that true?
Yes.
Yes, sir. Okay. Okay. It should be do like this. Otherwise, it's wrong, completely wrong. Okay. Now we have some question. We can have a lot of time. We have 8 minutes for question.
I can make a comment otherwise to what you have said. We have actually done some wear prediction for Chinese high-speed trains for the CRH3 high-speed train, and I agree it's a challenge, but we got quite good agreement between measured and simulated wheel wear. So I will show a picture tomorrow in my presentation. It is possible to get good agreement between simulated and measured wear.
Okay. Yeah, this is valuable.
I agree, it's a challenge.
Okay. Yeah.
So, have you just talked yourself out of a job with shift to rail? If you can already get good agreement without your new model?
Good question, yeah. Or good comment.
The other comment was you say about wanting to not extrapolate, but surely you're going to have material properties in your model which are extrapolated for the plastic deformation. You'll be doing tests on material, and it won't be at the same strain rate as in the wheel rail interface. There will always be extrapolation from models, and maybe it's safest to use extrapolation from a complete model than from lots of little bits of testing on different things.
Yeah. One big issue, I would say, is the ARCAD wear map that is used by everyone, that was developed under, as said, certain conditions. For example, for relatively low axle loads, we have used it to predict wear and RCF on an iron ore operation with 30 tons axle load. We did some calibration before, but yeah, it's not an optimal way to do it, to always use the same wear map. The only thing that basically is existing, calibrated for each new type of operation, and hope that it works. It works surprisingly well, but would feel better to have something else available also in the future.
Thank you.
Thank you.
Just regarding, sorry.
Yeah.
Please.
Please.
Oh, hello. Just continuing your theory, I do appreciate that the wear is, the asperities are quite important, and the global wear laws are not necessarily, will be a good direction. But in terms of that, having seen really high pressures, as you pointed out, orders of magnitude higher because of asperities, what would you think? Like, would the asperities not wear first instead of having to form that lamina and have the subsurface void, then the crack initiates and it grows, while your asperities are seeing such high pressures? Won't they just worn out before your laminas are formed?
I think that is a very valid comment. I've also, been thinking of. this is an initial state of the both contact partners, but then you wear away some material and then probably the surface gets smoother. But I think this is still also an issue for more research. How does wear really take place? There are some flakes worn off. How does the surface really develop in the end? I think we don't know exactly yet. There's still research ongoing to what is really wear.
No, maybe one model is not the answer, is basically what I've been thinking, and maybe that might be it. So.
Okay. Hello, I also have a question to Professor Stichel. I want to ask you, do you think it's a good idea to also consider the contact temperature, the wheel rail contact temperature, the influence of this temperature on the material properties by this new wear model? Or do you want to consider this?
Up to now, I think we have not thought about it, but I think it's certainly a good input, yeah. Why not? Because we know that the temperatures can rise quite significantly in the contact, which might influence the material parameters. So, yeah, thank you. Very good input, I would say. We are just in the very beginning of that. So.
Thank you.
I fully agree about the influence of asperities, and it cannot worn out, because you need to think about third body present at between.
Sorry, Maxime. Yeah.
I agree about all these asperities and influence on contact pressure and other stuff, and it cannot be worn out. You forgot that, for example, when you use it on network and you need to realize high traction force or just traction force, people use sand, and they put it as third body. And in this case, you remove one asperities, but you got another one. And the process is unstopped process. And in this case, you will always have these asperities. Maybe distribution of asperities will be different, but you will always have high contact pressure in some points.
That's what I meant. There will be more than one wear model going on, because what you are describing is the asperity-based wear models that do exist. And that's what my final comment was, that there might be the lamina. His proposal is a delamination wear. And what I was saying, that it may not be just one type of wear. You're going to wear out your asperities, going to form new asperities too. So you're going to have local asperity-based damage wear as well, in addition to the lamina damage.
Yeah, but in this case, you can avoid one reason, but you got another reasons. And what you are trying to say, let's go from other angle. So in this case, it's necessary to get model which will work and provide results which very close to operational practice. So if you can get some level of accuracy, you can say this model is okay for further implementation in simulation or other stuff. We don't need to get very accurate model. We need to get good workable model.
But there are models. They're out
Okay,
there.
left time for his answer. Professor Steve, would you answer this question?
I'm very happy to hear all this discussion, and I do not claim that we have the final solution here. As I said, we are just in the beginning of this type of new approach, and yeah, you are all welcome with more comments in the future. Thank you also for what you said. That's also my feeling. The topography does not just get
Okay, so yeah, we were
will
closing this session. Thank you for your hard working. Okay, Professor Steele and all others. Thank you.